In this part, inshallah, we will make some detailed drawings and make the flat pattern drawing for the roof and shell plates. Now from SEG Software we will select the roof, and from update plates we will select create flat pattern. Here, after selecting this, SEG will start automatically to create the flat pattern of the roof. Here, that's the last piece, which is the slice cut angle. If we double click on it, and from the iLogic browser here, you have the ability to make this slice from 2 pieces, and you can figure that it's this value shall be divided into pieces. And if you make it 4 pieces like this, you have the ability to control the angle of the cut like this. Let's keep it on 90 degrees. Now we will make a drawing for this flat pattern. From here we will select drawing and create drawing. Select the drawing size, and from the activation we will add the elevation view, and from here we will look from the front view. So if we take that like this, we will make it from the back view. The location and in X and Y, select define the scale, and from tables we will select bill of material table, and from here we will select some welding details. So let's come back to the end, and from here we will select this detail, that one, and that one. That's a detail for overlap, and let's click OK. And from here we will move flat pattern, drawing number, revision, okay, click save. Let's delete this. Let's add another rows here and click create. Now we will open Autodesk Inventor. You can figure that the view of this roof after flat patterning is done, and here the details. Now we will add some dimensions to the model. That's the center line. That's the bill of material of the roof, and here the information of the project, like the serial number that we defined, the manufacturer, drawing, the storage tank name, and drawing size, and here the revision table. Now we will add some dimensions, like the large diameter, or we could add it like this. Okay, and from here that's the mid plate width, that's the overlap. Okay, and if we wanted to make a detail for each plate of those, we have the ability to do it like this. And let's take a look from the back view to be the same here, and define the scale to be like this, and we could add the dimensions. Okay, another piece. For example, let's open this one, and from here we will add this piece, and let's take a look from the back view. Okay, like this. Okay, to make a nesting for this roof, we will do the next steps. From here we will select the assembly and select create nest, and from here we will select standard millimeter and click OK. OK, and here we have those plates. From nesting tool we will select the last piece and deselect it, and from here we will define the levered plate dimensions. Okay, and here and click OK. Now we will make a nesting study and click OK. Here we have the nesting result, as you can see here. Let's come to the small parts like that, and we have two halves, and that's, you can figure that that's the torch cut tolerance right here. So it should be defined in a correct way in SEG to make the length of the half plate is correct in nesting calculation, like this. Okay, so let's come back to the drawing here, and in this detailed drawing, if we measure the half plate, you can figure that the difference between those, if we by 2, so you can figure that the difference between them is 10 millimeters, which is the cut tolerance or the torch cut tolerance. Okay, now let's make another drawing for the clean outdoor. Now we will use another tool in SEG, which is SEG helper. This helper will help us in some drawings like clean outdoor and manual. So from drawings right here, we will select this clean outdoor, and from projects we will select the location of the project, which is a storage tank demo, and click create. Okay, now we will come back here and go to the clean outdoor and open the assembly. And from VI Logic Browser right here, we will make some modifications to make this one looks like the same that we did right here. So if we come back to the clean outdoor, it's 36 by 48. So let's come back here. No problem regarding to the orientation and the projection. $175 for the projection, and the neck thickness is 14 millimeters. The flange thickness, if we come back here, flange thickness is 20, and the cover thickness is 24. Okay, gasket thickness is 3, blind thickness is 24, and bad cut clearance, the handle, the length of the handle, davit, dimension of the davit, the materials, and from here we will define the tank inside diameter. Shell course thickness, blade course length, opening cut clearance, the thickness of the annular plate, edge length, arc length, projection, here that's it. If we wanted to make this edges curved, we will select this one. So if we take a look, so you can figure that this edge is curved, and if you wanted to make it as a sharp edge like this, just remove this checkbox. Now we have this 3D model for the clean out door. Now we will click save, and we will open the detailed drawing for the clean out door. From here we will go back to the drawings and open the detail of the clean out door, and from here you can figure that that's standard drawing, pre-built drawing for the clean out door, and here that's the dev drawing. So we will make some modification. From here we will make update sheet to update the scale of details inside this drawing, and let's minimize the scale of those right here and minimize the spacing between them, minimize the spacing or the scale for this detail and for the reband detail. Now we will make some modifications by hand, like arrange some dimensions like this to make it make sense, not more or less, like that. The same for the last view here. Okay, now we will come back to the second drawing of the David and make the same adjustment of the dimensions. That's the David drawing. You could adjust the scale to adjust the scale a little bit, and for the spacing the total weight and the bill of material. Now we will click save. Now we have those detailed drawings for the clean out door and the clean out door depth. Now we will make the sheet metal flat pattern for the shell, which is called shell development. From here we will select this one on that tab on the assembly shell development, and you can figure that that's the shell development for each plate, and those are the shell courses here. Okay, from CAN 1 at the bottom up to CAN 5. Now from here we will create the flat pattern by clicking on this button and come back to the model. Now we will create the drawing for this one. From here we will select drawing and select create drawing, select drawing size and the elevation. From here we will take a look from the front view. Okay, so let's take a look from the front view, find the location. So here, as you can figure, after creating the shell development pattern, that's the arrangement of the welding lines from 0 degree up to 0 degree right here, and you can define the height of each course like this. So if we need to make it as a chain, from chain we will select this one, and if I continue to make it like this, and if you want to make the same for those, it will be like that. So if you wanted to make it for any level, you can make it easily like this. Okay, and you can have the ability to change the scale. If we come back to the drawing and if we click edit from here, we can increase that one and change the location. Let's click create, and you can figure that the scale is changing 1 by 110, and that's the bill of material. And you can change the scale of or the size of the drawing from here if you would like to change the drawing size. Now we will make the general arrangement for the tank. So from here we will select the tank and select create drawing, and from here let's select the drawing size and the views. Let's select the elevation view and the bottom view and define the spacing between them. And the elevation, we will look at it from the back view, and from here we will define the location of the view. We will make the bill of material appear, design drawing, flange table, and nozzle table. We haven't fitting or something like that. Notes, if you want to add any notes, you can add it or edit or delete from the standard. Select some welding detail, standard welding details from the library. Client document list and visual document list, revision table, and now let's click create. Here, after importing the information, we will move some tables like that from here to there. Okay, and we could make some hand modification for that one. Let's break this and move that one right here, so we have the elevation besides the top view, and here we have the welding details, and we could move them a little bit like that. And from here we have the ability to add 3 dimensions, chain dimension for the height, continue, and for the inside diameter of the tank, okay, we will get some standard to that. And clean outdoor. That's the other nozzle, which is N1. The elevation for this nozzle. The projection. So you have the ability to add your dimensions, and by using SEG you can get the automated bill of material in minutes, general notes, client document list and visual document list. The nozzle table includes the service of the nozzle, size, outside diameter, orientation, thickness, schedule, flange if there is attached flange, and another information about welding detail. Here, that's the 3D model of the tank which we created in this demo.